Section 11.1, number 26, the sequence 2n plus 1 over 1 minus 3 square root of n. I need to decide if this converges, diverges, and if it converges, show what it converges to. Okay, I'm going to first examine this by doing the usual thing of dividing by the square root of n. That will leave me, I suppose, with the square root of n, 2 times the square root of n plus 1 over the square root of n, and downstairs 1 over the square root of n minus 3. Okay, so as n becomes very, very large, this will go to 0, and I'll be left with the 2 square root of n up there. That will go to infinity, and downstairs I'll have a negative 3. So this is going to go to, the numerators become very large, and the bottom's going to stick near negative 3. So this is going to go to infinity. Well, okay, the numerator's becoming very, very large, but the denominator's a negative number. So I'm thinking this is going to go to negative infinity as n goes to infinity. Now that is an emotional statement. In order to verify it, to prove that it's the case, we need to go back to the definition of divergence to negative infinity. Since if, let's take m, if we have m, a real number, then we want to say that 2n plus 1 over 1 minus 3 square root of n is going to be less than this thing, m. We want to say that it's less than m when n is big enough. It's not really clear how to do that yet, so let me just make some modifications first. I want to have a string of inequalities, of less than signs that ends in m to guarantee that this thing is less than m. So let me say that I'm going to put in an expression with a bigger numerator. What's bigger than 2n that's convenient? 2n plus n is certainly bigger. 1 minus 3 squared of n, I'll keep that down there. Okay, so that in turn, this numerator 3n can stay there. This is even, okay, another bigger thing. I can replace the denominator with something smaller than the denominator in order to get a bigger thing. So negative 3 square root of n, that is to say, I am replacing that 1 with a 0. Okay, you see how I've replaced the denominator with something smaller than the denominator to get a bigger expression. Okay, so that is negative square root of n. Okay, so I can say with confidence that that is less than m by putting a simple condition on n. If n is sufficiently big, bigger than something I'll define as capital N, which is going to be a function of m, and it looks like I can define that function to be m in absolute value. So if m is a negative number like negative 1,000,000, then this is 1,000,000 and m squared. Okay. So if n is bigger than absolute value of m squared, think about that here. If you have something even bigger than the absolute value of m squared, negative absolute value of m squared, square rooted, so negative absolute value of m, so certainly it's going to work. Okay, so indeed there is some integer. Now, once again, n sub m, the way I've defined it here might not be an integer because we didn't say that m was an integer. So what I'll do is I'll add in the ceiling function. After I square the absolute value of m, I apply the ceiling function to get the next biggest integer.